Going to review what we have done so far in Chapter 2, and we will start with solving systems of equations. So here is a 2x2 system, two equations with two different variables, and this one has y by itself already, so what I think I would do is substitute that value in for y. So that y becomes 10x minus 8, and then plus 4x equals 13. Okay, so on this side, we could combine these like terms. So we get 14x minus 8 equals 13. I want to add that 8 to the opposite side and get 14x equals 21 and divide both sides by 14. So x is 21 over 14. And 7 goes into both of those numbers, so that can be simplified. 7 goes into 21 3 times and into 14 2 times. So I get x equals 3 halves. Okay? Then I can plug that into either one of these two equations. I think the bottom one's going to be the easier one. So y equals 10 times 3 halves minus 8. So 10 times 3 is 30. Divided by 2 is 15, so we get y equals 15 minus 8. And 15 minus 8 is 7. So these two lines intersect at the point 3 halves 7. It's important to plug answers back in and check. We're not going to take time to do that here in the video, but if you plug 3 halves and 7 in for x and y in both equations, you should find that you get true statements here. So do that, check it. On number 2, we've got a 3x3 system. 3 different equations, and I've got x, y, and z, so 3 different variables. On this one, I also used substitution. Now, our aim when we have a 3x3 system is to somehow turn it into a 2x2 system, whether that's by elimination or by substitution. So what I did is I switched these two, the negative y and the 11, and that gave me 2x minus 11 equals y. So I have y by itself, and I can substitute that anywhere that I see a y. I'm going to put it right there. So I've got 7 times 2x minus 11 plus 2z equals negative 23. So that's 14x minus 77 plus 2z equals negative 23. Okay, and I can move this 77 over. So I'm going to add it to both sides. 14x plus 2z equals, and then negative 23 plus 77 is 54. Okay, so now I have two equations with an x and a z, right here and right here. And I've got a negative 2z and a positive 2z, so those two are set to cancel. So if I combine this equation and this equation, 5x plus 14x is 19x. The z's cancel, and then 3 plus 54 is 57. And then I can divide, and 19 goes into 57 3 times. So I've got my value of x. I think the easiest place to plug that value of x in is right here. 2x minus 11 equals y. So 2 times 3 minus 11 equals y. So that's 6 minus 11, which is negative 5. Okay, and then I can plug into any equation with a z to get z. So I will use this middle equation, 7y. So that's 7 times negative 5 plus 2z equals negative 23. Okay, so that's negative 35 plus 2z equals negative 23. And when I add 35 to get it over to the other side, I get 2z equals 12. And divide both sides by 2, and I get z equals 6. Okay, so I've got 3 lines in an x, y, z coordinate space, and they will intersect at the point 3, -5, 6. And again, it's important when you're doing these on your own to plug those answers into all of the equations and make sure they produce true statements. In number 3, the only place I could get x or y by itself is here in the first equation because the other ones have 3 variables. However, 13 isn't divisible by 2 or 3. I don't really like this one for substitution. I'm going to use elimination. So I want 2 equations with 2 variables. And right here, I've already got one equation with just an x and a y. So it's in my best interest to make another equation with just an x and a y. So I'm going to use these bottom 2 to cancel out the z's. So I'll do that by multiplying this one by -2. So I get -2x plus 2y plus 2z equals 4. And now the z's are going to cancel. Okay, so I can combine those 2 equations. 7 minus 2 is 5, so I've got 5x. 5 plus 2 is 7, 7y. The z's canceled, and 28 plus 4 is 32. So I now have 2 equations, each with an x and a y. Okay, so I've got to use this equation and this equation to solve for x and y. So I think what I'll do is cancel out the x's. I could multiply, say, this top one by by -5, and this one by 2, and that would cancel out my x's. So I've got -10x minus 15y equals, and then that would be -65. Okay, and this one by 2 is going to give me 10x plus 14y equals 64. So my x's are canceled. -15 plus 14 is -1, so I've got -y. -65 plus 64 is -1, so y equals 1. Okay, I'm going to plug that into the top equation. 2x plus 3 times 1 equals 13. So 3 times 1 is 3, so I'm going to subtract 3 to get it to the other side. 2x equals 10. And divide by 2, so x is 5. Okay? Clearly, the easiest place to plug those in and solve would be this last equation. So I've got 5 minus 1 minus z equals -2. So I've got a -z. I'm going to move that to the other side, and I'm going to move that -2 to the other side. So I've got 5 minus 1, which is 4, plus that 2 is 6, equals z. So these 3 lines intersect at the point 5, 1, 6. And in our last set of equations here, I think the easiest thing to do is going to be to eliminate the z's. So if I combine the top and the bottom equations, 4x and x is 5x. -2y plus 3y is 1y. And then z minus z cancels. And 30 minus 27 is 3. Okay, so those z's are canceled. Now I'm going to have to cancel z's one more time, including using that middle equation. So I will multiply the top equation by 2. So that's 8x minus 4y plus 2z equals 60. And I'm going to combine those 2 equations. Okay, so that's going to give me 13x. -4 plus 1 is -3y. And then 60 plus 1 is 61. Okay, so now I have an equation here and here, both with an x and a y. I could eliminate the y's pretty easily if I multiply this equation by 3. I'm just going to bring that right up there. 15x plus 3y equals 9. And the y's will cancel. So I get 28x equals 7. Right? So I'm going to divide both sides by 28. And I can actually divide 70 and 28 both by 14. So that's going to give me 5 over 2. So that's my simplified form, 5 over 2. So I think I'm going to put that right into this equation, 5x plus y equals 3. So 5 times 5 halves plus y equals 3. Okay, so 5 times 5 halves, that's 25 halves, plus y equals, and when I move this 25 halves over, I'm going to have to subtract it from 3. So I want to take this 3 and write it with a common denominator. So I'm going to multiply top and bottom both by 2, so I get 6 halves. And now I'm going to subtract 25 halves. Okay, so 6 halves minus 25 halves is negative 19 halves. Okay, and I think the easiest place to plug that in and solve is going to be the bottom equation. Okay, I can do it in any of them. I'm choosing the bottom. Okay, so that is 5 halves plus 3 times negative 19 halves minus z equals negative 27. Okay, so I'm going to move that negative z over, move that negative 27 over the other way. So 5 halves. Okay, and then 3 times negative 19 halves is negative 57 halves. And then as I bring this 27 over, I should multiply the top and bottom both by 2. So I'm going to get plus 54 halves. Equals, and then that negative z goes to the other side and becomes positive z. So 5 halves. So 5 minus 57 is negative 52. Plus 54 is positive 2. So I get z equals 2 over 2, which means z is 1. So these intersect at 5 halves, negative 19 halves, 1.